Good day, everyone. I am teacher Loresa and I am your physics tutor for today. Today we will discuss about resistors connected in series and in parallel.
The learning competency is to evaluate the equivalent resistance, current, and voltage in a given network of resistors connected in series and or in parallel.
First, we will differentiate circuits connected in series and in parallel. Second, we will calculate the value of resistances of circuits connected in series and in parallel.
A circuit is in series if there is a single conducting path for the components that are connected on it. Circuits are parallel when there are multiple paths for the current to flow through. Let's look at the physics education for teachers simulation for a deeper view of what is series and what is parallel. Now, we will use the physics education for teachers simulation for the circuits for series and parallel. So, we will construct first series circuits. So first, I will use 3 bulbs to show you how a series connection is. So I have here 3 bulbs and we have the wires. The wires should be connected from a positive to a negative terminal, series connection. So these are the wires for the series connection. Now I will put a switch. Okay, let's have 3 batteries for the power source. Now, the circuit is complete for series connection. Now, if I switched on this one, observe what happens to the circuit. If you look at this one, the electron would flow in one direction. For a series connection, let's observe what happens to the voltage if we connect voltmeter across each bulb. Look at the value of the voltage. If I connected a voltmeter across the first bulb, its value is 9 volts. If I connected again the voltmeter across the second bulb, look again at the value. So, it is 9 volts. Let's move on to the next. I connected the voltmeter on the third bulb. What is the value of the voltage? Again, as you can see, it is 9 volts. Now, if I connect the voltmeter across 3 bulbs, what is the value of the voltage? As you can see, it became 27 volts. If I connected the voltmeter across these batteries, it's also 27 volts. What could you conclude about the voltages connected in series? Now, let's create a parallel connection. So first, we have batteries. Okay, and then let's connect the battery to a switch. The batteries to switch to a switch. And then let's have the wires. Now, for parallel connection, unlike series, that there is only one path for the electrons to flow. So for parallel connections, you have different paths for the electrons to flow along the circuit. So this is how we are constructing a parallel connection. So this is a series connection. First, we will have a junction and then connect it on the bulb. Okay? So this is what we call a parallel connection. So parallel connections are said to be parallel because of the presence of its junction. Now let's look at what happens to parallel connections if we remove one bulb. As you can see, observe what happens. As you can see, the other bulbs still lights up. Compared to the series connection, when one bulb is busted, then the other bulbs would not light up. In summary, from the simulation, you could see that resistors are in series if there is a single conducting path. It is in parallel if there is what you call a junction. For the currents, it is the same for each resistor, whereas if it is connected in parallel, the sum of the current is I total is equal to I1 plus I2 plus I3. For the voltage in series, V total is equal to V1 plus V2 plus V3 and so on. Whereas for voltage connected in parallel, it is the same for each resistor. To compute for the equivalent resistance of resistors connected in series, you just simply add it up. Whereas, to compute for the equivalent resistance of resistors connected in parallel, you have to get the reciprocal sum of the resistors. Now, let's calculate the total resistance of this given circuit. For example, your resistance 1 is 2 ohms, your resistance number 2 is 3 ohms, and your resistance number 3 is 4 ohms. So what is the total resistance of the given circuit? So, since this circuit is in series connection, you just simply add it. So it's just 2 ohms plus 3 ohms plus 4 ohms, and it would be equal to a total of 9 ohms. It's easy, isn't it? Now, let's look at the following example. Let's compare the first example from this second example. For this second example, the resistors are connected in parallel. So what is the total resistance of this following circuit? So since these are in parallel, we use the reciprocal sum formula. So we have 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3. This becomes 1 over 2 ohms plus 1 over 3 ohms plus 1 over 4 ohms. Using your calculator, you will have a value of 1.083. But take note that the R is still on its denominator. Hence, to bring out the R total, you have to get the reciprocal. Hence, you will have to input the inverse of this one on your calculator, and you will have a total resistance value of 0.923 ohms. So this is the total resistance of these resistors connected in parallel. Let's try the following combination. As you could see, this circuit is a combination of both series and parallel connections. So how do we compute for this one? First, you have to simplify first this parallel connection. So what will happen to this circuit? This circuit becomes like this. So it would become 2 ohms here. These parallel connected resistors will be combined. So what is the value of this one? So using the formula, 1 over R total, you have 1 over 4 plus 1 over 4 ohms. The total resistance for this parallel connection is 2 ohms. Now this answer here, you will place it here, so that this simplified version of the circuit has 2 ohms of resistance at this portion. Now, if you look at this circuit is already in series. If this is in series, you have to just simply add this one. And by simply adding 2 ohms plus 2 ohms, you will get a total resistance of 4 ohms. Yes, the total resistance for this circuit is 4 ohms. Now, let's have some quiz. Number 1. A 9-volt battery is hooked up to 2 resistors in series. One has a resistance of 5 ohms and the other has a resistance of 10 ohms. Several locations along the circuit are marked with letters as shown in the figure. Through which resistor is energy being dissipated at a higher rate? The answer is 10 ohms. Why? From the previous lessons, R is equal to I squared R. Since this is in series connection, the current is the same for 5 ohms and 10 ohm resistor. So, the higher the resistance, the greater is the power. Number 2. The lamps in a string of decorative lights are connected in parallel across a constant voltage power source. What happens if one lamp burns out? First choice, the other lamps get brighter equally. Number 2, the other lamps get dimmer equally. Choice number 3, the other lamps get brighter, but some get brighter than others. Number 4, the other lamps get dimmer, but some get dimmer than others. Number 5, the brightness of the lamps will not change appreciably. So what do you think is the answer? Yes, you got it right. The answer is choice number 5. Why is it that I had choice number 5? Take note that for parallel connections, the voltage is constant. Even if one lamp burns out, the voltage is still the same across each bulb. Hence, the brightness is not affected when one burns out. Question number 3. 4 unequal resistors are connected in a parallel with each other. Which one of the following statements is correct about this combination? First, the first option is the equivalent resistance is equal to the average of the 4 resistance. The equivalent resistance is less than that of the smallest resistor. Third option, the equivalent resistance is midway between the largest and smallest resistance. Fourth option, the equivalent resistance is more than that of the largest resistance. Take note that the resistors are connected in parallel. So which of the following is the correct answer? The answer is the equivalent resistance is less than the smallest resistor. Take note that for resistors connected in parallel, it is the reciprocal of its sum. Hence, from this formula, you will have a lesser resistance. Question number 4. As more resistors are added in parallel across a constant voltage source, the power supplied by the source A decreases, B does not change, C increases for the time and then starts to decrease, and D increases. What do you think is the answer? Yes, the answer is it does not change. Take note that when resistors are connected in parallel, the voltage is constant. Now, let's proceed to the last question. As an application of what we have learned, draw a circuit with a battery connected to 4 resistors R1, R2, R3, and R4 as follows. Resistors 1 and 2 are connected in parallel with each other. Resistors R3 and R4 are connected in parallel with each other, and both parallel sets of resistors are connected in series with each other across the battery. So what do you think is the answer? Have you figured it out? Yes, the answer is this first option. Congratulations for taking the quiz.
Thank you for listening and I hope you learned something from me.